All right, well, here's a few news articles that are fun. This one here I thought is a lot of fun. We've been going through a lot of projects doing this attack in the malware analysis class. This malware that's affecting people in Brazil to steal their banking credentials replaces a DIL. DILs are Microsoft's dynamically loading libraries, and it replaces a DIL used by Zoom. This is a very common weakness that the libraries are loaded from a location that's not specified, so the system hunts for them in various folders, and you can trick it into loading the wrong one. So they hijack a DIL, and then so you can add new code to running processes. And this adds new code to Zoom, which is then used, this one here, cmmlive.dil. So we've got homework where we're doing exactly this with a variety of techniques. It's a very common way. It's the most common way that malware gets on Windows machines, is with these dynamic link libraries. So this is something Trump just said at one of his rallies where he's saying lots of crazy things, but he says to get hacked, you need 197 IQ. So that's about as true as everything else Trump says. Anyway, so Trump's now on the warpath against Fauci, saying that Trump said that Biden is such a rotten guy that if he gets in, he's going to listen to scientists. So Trump is very proud of not listening to scientists and not doing what scientists say about the virus. And he's been preventing Fauci from going on talking about it. And, you know, Fauci seems to be more and more open about saying the opposite of what Trump is saying now that he's like deliberately spreading the virus and telling people that masks don't matter and stuff. But so anyway, hopefully Biden will get in, and sometime around February next year, we can begin trying to handle the virus instead of just pretending it's not a problem and ignoring it, which I think there's no chance of any of that changing until Trump is out of there. This is pretty incredible. This is rating the quality of COVID response in America. And as you can see, it is incredibly bad. Almost every state is in the worst category of uncontrolled spread. There's only 2 that are in any good category. And it's just amazing. And when they survey Republicans, a large percentage of them think everything is fine because they just believe what Trump said. This is something that Hitler said, that you do well with the big lie. There's a large group of people who will just believe whatever an authority figure says, even when there's no truth in it and the evidence against it is right in front of them, which I think, you know, gets back to the fact that humans are herd animals. We have an instinct to conform to the group. And many people place that instinct of conformity ahead of the figuring things out for themselves, for better or worse. So almost all local newspapers have gone broke and vanished, which people are saying is the root cause of a lot of the crisis in American politics, where we no longer agree on what the truth is at all. But instead, there's now fake local newspapers. There's a pay-for-play network that takes money to push conservative agendas, and they produce these fake duplicate papers, which pretend to be a local paper, and they aren't. And this is also true, something I heard 20 years ago that just increased, is if you call radio talk-in shows, most of what you're hearing is paid advertising. The conservative groups send out documents for people to read into those things. And anyway, it's like fake reviews on Amazon and Yelp and such. A lot of what is supposedly grassroots people is in fact paid advertising. There's a capture the flag coming up. It's supposed to be easy for beginners. Coming up in October 30th to November 1. This is run by Irvin's students, local group, so it should be fun. You'll find Cyber Yoda here in the news links. I'll probably add it elsewhere, or anybody does this, it's worth extra credit. Probably won't be too hard. Be up in a couple weeks, be a good thing to do. And by the way, we have a guest speaker coming down here. Caitlin's going to come talk to us about attacks on systems that are off the planet in space. So that's Tuesday, November 3rd, and that's also worth extra credit. You have to tune in. It won't be recorded. And so in case anybody still thinks that a vaccine is going to come and it will end coronavirus, that is almost certainly not going to happen. That did not happen to the 1918 virus. What happened is it mutated to a more contagious but less lethal form, and it's still with us, and it's the seasonal flu that you catch every year. And something like that will happen with COVID-19. It will just become another disease that, instead of being a pandemic, or an epidemic, which means it's spreading uncontrollably widely through the population, if we get some reasonable number of people vaccinated, like 70 or 80%, then it won't just spread through the whole nation like we had in that map where all the states are in red. There'll just be outbreaks here and there. And it'll just be one of those diseases that's around. It's extremely unlikely that we'll be able to completely eradicate it like smallpox. That is an incredibly difficult thing to do. But with a vaccine that we might reasonably expect to be available in the passage of a few years, we might get it down to one of these diseases that is not just spreading wildly everywhere, but just has occasional outbreaks. Like there's a lot of them out there, Legionnaire's disease, and so on. So Chinese hackers are impersonating McAfee antivirus on Joe Biden's campaign. So that's a new trick. That's how they trick people into downloading this stuff. I'm not sure how good they are. I don't think they were able to imitate a McAfee signature, but they're able to create screens that make it look like McAfee. And this is an interesting issue. There's one of the old questions in physics is Maxwell's demon. This is the arrow of time, it's entropy. Things naturally become more disordered. And so if you start with hot gas on one side of say a room and cold gas on the other, then they will mix until you just have an average temperature throughout. And the question is, how does that work and what does it do? And in any case, they've discovered that in quantum mechanics, there is, I think, no necessary cost of this. Whereas in normal mechanics, there's a certain cost for sorting things and measuring things. But in quantum mechanics, it works out quite a bit differently. And here's, I find the new findings. Yeah, computers, in principle, there is some heat involved in sorting things and measuring things. But in quantum mechanics, there are rare events that dissipate much greater amounts of heat. So that means they're hoping to be able to measure this. And anyway, it will prove something about the fundamental limits of the ability of quantum computers to compute things. This is where a lot of modern research in quantum mechanics is going. There's this bizarre thing in quantum mechanics where this uncertain state of particles goes through something called a measurement and collapses into a certain state. And nobody has ever understood how that happens. There are several arguments that almost become religious arguments about how this happens. And many groups are now closing in on a careful measurement to find out exactly what causes that and exactly what can be done with it. And thoroughly understanding that process might lead to a lot of useful technology. Anyway, let me go on to the official stuff. I come back tonight at 7. Sure, anybody wants to come back at 7? Yeah. Yeah, sure. Come back and I'll see if I can figure it out. All right. So coronavirus. 4 kinds of coronavirus cause regular flu. Yeah, that's right. The death rates of COVID-19 and SARS are 100 times more than regular flu. Well, that's interesting. From what I've heard, people said that the coronavirus 19 is maybe 5 to 10 times more deadly than the normal flu, but it may be more. I think they're not entirely sure. But anyway, that's it seems like America is going to be the guinea pig to find out what happens if you do absolutely nothing to control it. And if it's like the other ones, what will happen is it will eventually spontaneously mutate to a less lethal but more contagious form, which will replace the others. But we will see. It's certainly more deadly than the regular flu. Exactly how much people seem to be arguing. Anyway, so we're here at 152, and it's network evidence today. So let me bring that up. All right. And we've already talked about this. There's a project for Wireshark, which I think you folks have already done, or at least we've talked about it. Let me bring it up here. Yeah, if you go down here to the networking, here's where you had a Wireshark project where you hunt through packet captures to find evidence, and that's essentially what we're talking about tonight. So, all right. I'll make this bigger if I can get a handle on it. There we go. All right, so you need to monitor network evidence. It's extremely important, extremely useful for instant response. The one great thing about network evidence is that it can't be erased by malware on a server that tries to erase the logs. That's one thing. And also, you can measure network evidence at some place like the gateway to the internet, and it gives you information about a whole network segment, so you can find out what's happening on computers without examining them directly. So it's definitely an important part of your incident response and your monitoring to detect security incidents. So there's 4 ways to monitor a network. You can have intrusion detection systems that create events. You can capture the packets and save them. You can store session information about the connections, how long they go, and how much data is moved. And then you can just have high-level summary statistics. And those are all useful for different purposes. The simplest, most obvious one is event-based alerts. This is basically antivirus for your network. Things like Suricata and Snort. They just have a list of definitions of known malicious traffic. And when they see malicious traffic, they do something like send out an alert, put in a log entry, perhaps change a firewall rule, something like that. Recording whole packets or all the headers of packets is also quite easy with TCP dump or many other tools. And that's one way to keep track of what's going on in your network. It does suffer from the same problem as whole disk images. You get way too much data. Of course, the vast majority of the network traffic is harmless, so you have these gigabytes of stuff, almost all of which is just boring network traffic for normal, and then you have to hunt through it and find the bad stuff. So although in principle it's more complete, like a hard disk image or a complete RAM image, it's not the most efficient way to catch a nasty thing right away. So then you have high-level statistics. This will show the number of packets of different types and where they went. And then should be a 4th one. Oh, I missed one here. Headers of full packet, event-based alerts. Yeah, and session information should be in here someplace. Anyway, a session information is similar. That's like what NetFlow does, where you have just a record of who connected to who and how much they downloaded. And the original purpose of that, by the way, was to just charge people at internet service providers. We can see how much you're using and then limit you or charge your bill. But it still is useful to see what's going on. And if you have some people downloading big movies or running BitTorrent or some infected machine doing something that uses a lot of network traffic, you can find it just by seeing which machine has an unusual amount of network traffic or an unusual type of network traffic. All right, so event-based monitoring, we talked about it just looks at rules and notices when something is bad. So you have to have signatures. And it's very easy to make mistakes when you write your signatures. So if you make a complicated signature that has to do some complicated mathematics on each packet, then the processing engine inside your monitoring device will not be able to keep up, and it will either miss the signatures or miss packets. So you try to write indicators that are pretty simple, like just an IP address and a port, not anything too complicated. So here's a Snort rule that will detect SSH brute force attacks, and Snort is the standard. Snort was the first product that became popular for this, and it set the standard for how to write these rules. So it's going to send a TCP rule, and here's the message it's going to put out, brute force login attempt. And so here's what it does. It looks for an SSH, more than 5 events in 60 seconds with this type of activity. There's a special format to this. It takes practice to write these rules well. So you put that in a Snort configuration file. This is one way to output it. That will just put it in a file called alerts. And that's all Snort does. You might have something else that does something more with those alerts. And so it can get pretty complicated. Here's a fake certificate used by an advanced resistant threat group in 2003. And as you can see, it's pretty complicated. It looks for a URL here. It looks for a mail.aol string there after a 0C byte, and rules this string has to be within a certain distance of that string, and so on. That's a fairly complicated rule, like a regular expression, to detect that sort of traffic going over the wire. All right, then you got headers and full packets. You can record the headers of every packet, or indeed the full packet, and then you have much more complete information about what happened. Full packet logging is the only thing that makes it possible for you to actually reconstruct the entire files that were downloaded, although you probably can't really do that anymore now that we're all using TLS 1.3 and every session has a separate encryption key. Back in the old days when you would transmit things with unencrypted protocols like HTTP and FTP, that was more useful. These days, I think there's less and less point in preserving full packets because it's probably encrypted anyway. So the header is probably all you want, but there may be some cases where you do this. A lot of enterprise class networks do man in the middle all encryption and have a place where they decrypt it and analyze it. So they do have a special place in their network where they have plain text for everything. and they encrypt it on both sides of that. So that would be a case where you might be worth preserving the whole packets. So, all right, the IDS systems can generate the whole session, but normally you use TCP dump to monitor it, and then Wireshark to analyze the packets. I've mentioned before, you won't want to use Wireshark for a live capture. It's not designed for that. It's not secure enough for that or stable enough for that. TCP dump is. So TCP dump is a command line tool. You run it, and you can either use a command line switch like -X to capture the whole packet, or you can limit it to just the first 64 bytes of every packet where you get all the addresses and protocol information, and you don't store everything. All right, so then there's statistical monitoring, like say NetFlow is the original one. This just keeps track. It's modeled after the pen test registers of telephones. Long distance telephone networks just have a record that goes on your phone bill. This number called this number at this time for this long. And then they can calculate a bill. And this just calculates the same kind of information. What IP address went to what other IP address, what kind of traffic, and how long did it go, and how many total bytes were sent that way. All right. And then there's statistical monitoring, where you have some kind of visualization tool to show it, and you can buy special devices you put on your network to analyze traffic. And this is an easy way just to see what's going on your network, and then you can track down problems and people that are using too much and things like that. So there are open source tools like Flow Tools and Argus. Here's a tool that will convert it to an Argus format and then graph these packets with Argus commands. It's used in Security Onion. I used to teach a network security monitoring course using Security Onion for a while, and it didn't work very well. It's been updated. It might be better now. It didn't work very well, and I quit using it. But it is the open source way to do all these things. And you get these graphs, so you can see bits per second against time, and see here's an unexpected area of high activity. One thing that is notorious about network traffic is that even normal legitimate use tends to be very random. People download a big file, then they don't download anything else. They turn on some weird chat client or video stream. It's not true at all that you expect to just have steady traffic, and if you see any spikes, that means something bad is happening. It's much more chaotic than that. So hard to tell. But then here you have a log scale. So this is a factor of 10 and another factor of 10. So this is 100 times above background. And that does mean something happened there, although not necessarily something malicious. Anyway, that Argus was one of the many tools in Security Onion, and I used it for a while, and then I decided to just go to Splunk instead. Splunk is the industry standard. It's expensive, but worth it. So I think this is chapter 8. Chapter 9, okay? Chapter 9 is here, okay. And I remind you, by the way, with these Kahoots or extra credit, some people said they were too difficult and too competitive. You can ignore them if you like. It's just an opportunity to earn extra credit, and some people enjoy them. That's all. Certainly not required to do them. I'll give it a few more seconds. All right. Any more coming? I guess not. Ah, here, okay. All right. I'll give it a little bit longer. Let me check my chapter 9. All right. All right. Let's go ahead. All right. Which monitoring lets you reconstruct files? All right. You got to have full packets for that. The headers are not enough. You won't have the contents of the file. All right, what does NetFlow do? Yep, that's high-level statistics. It's not events. All right. All right, what does Snort do? Those are events. You're looking for certain patterns and taking certain actions to trigger on them when they happen. All right, what kind of monitoring does TCP dump minus X perform? All right, that is full package. All right, so XC, okay, I think that's a real set of initials. Barbara's on who that is. Wilson, good. Those are all real enough names. In fact, I see XC right there. All right, good. So let's go back to here. All right, so you want to set up your system. One thing you can do is get a network tap, a little hardware device, looks like a hub or a switch. And this is the best thing to do, by the way, because it's hardware dedicated for this and it's more likely to keep up with the flow of traffic. So you put this in and have your traffic go through it and have an extra copy of every packet that goes by. All right, one problem with these things I mentioned before is they have a hard time keeping up with line speed traffic. Networking devices are in fact a lot less powerful than you might think. One thing I heard from people at Cloudflare is they would buy 10 gigabyte switches with 24 ports, and they really wanted to have 10 gigabytes going in each one of those 24 ports all the time, and the switches can't handle that. They don't have enough buffer for that. They have a protocol that can move 10 gigs, and they have 24 ports, but they assume that only a small fraction of them are active at any given time at full speed, and they don't really design it for full speed down every port. And there are a lot of other limitations. So your IDS platform might be 10 gigabits, but it might not be able to keep up with 10 gigabits per second of real traffic. And if you set it to capture full content, that will occupy the processor and it won't be able to do as much analysis of each packet, and so on. So you have to carefully watch the limitations. It is not at all true that you just take the speed rating of the port and assume it can handle all the traffic up to that speed and you don't have to worry about it. It's far more complicated and limited than that. So you have to define your goals. Of course, make sure you have the legal right to monitor the traffic you're monitoring. If you're at a company on premise, then you presumably have legal authority to monitor all the traffic generated from the company. But if you're monitoring people off premises, it's going to be more of a problem. Anyway, then you install your hardware and software and check your data. It is extremely common that you can't really measure all the traffic coming out of your network. And of course, you have people that use VPNs, either from companies or home, and then you add a layer of encryption that is presumably out of the control of the company. And so they're going to get, all they're going to know is the total amount of bytes you moved. They're not going to know who you are or where you're going if you use a VPN. They'll know the origin, but they won't know the destination. Destination will just be the VPN concentrator at the other end. All right, so it's hard to do. You might have to pay for special hardware for this. You can get servers. It used to be almost all firewalls and monitoring systems use FreeBSD. Now Linux is apparently better. The issue is exactly what kernel routines are used to handle packets. And Linux used to be an underperformer there, and they've recently updated it to a different kind of network socket that is faster. Although all the products I've used are based on BSD. So if you plan ahead, you set up some good monitoring. So you combine, I should have an I here, let me put it in. All right, anyway, so you can buy a commercial product that gives you a storage device and some kind of filtering. And here's a couple examples, Solera and RSA. I mentioned already Security Onion. It's a free Linux distribution, so you don't have to pay for any of the software, but there's no getting out of the fact that you're going to need a powerful server to store and analyze and gather all this data. It's got various analysis tools to give you a graph. Here's the DNS queries that are made, and you have nice colorful bar charts of things. All right, so when you deploy this, consider your egress points. This is actually quite a problem. For example, if you measure only the data going to the internet, then the data inside your company from one device to another is not being measured. And maybe that's all right, and maybe that isn't. There's a new technique of speeding up networks called multipath TCP, where while I'm downloading a file, I might have multiple exit points for my network, and some of the packets go through one and some through another. And this makes the downloading faster, but it totally messes up monitoring. Now I'm going to have to collect monitoring from multiple places and somehow put it all back together if I want to reconstruct the streams. So there's a lot of considerations here. It turns out that you often have to deploy network sensors at several points on your network, and you have to accept that you're not really going to cover all the traffic. So as with all security products, you have to do threat modeling and decide what you're trying to prevent and focus on preventing that, and decide what risk is not important enough to waste time chasing it down. Also, a lot of traffic is encapsulated in other protocols. The IP addresses are changed at things like load balancers and packet things that change the packets, DHCP and so on. So there's really quite a job, network address translation, spots. So, if you are a big company, you're going to actually have traffic collected at different locations in different time zones. So it really can be quite a chore to correctly gather all that data and make it useful. So if you make network changes, you might make your life simpler by forcing all the traffic to go through one place. So gather it all, go to one point of presence where you can monitor it all and send it on. That would be an option. Of course, this will slow things down and cost you some hardware, but it might give you more control. And it's the usual balance between convenience and cost and security. All right, so you can put your sensors someplace. Wherever you put your sensors, they have to be secure. So they should be in a locked room. If you're planning to ever go to court and prosecute anybody based on this sensor data, you really should have it locked up and secured by patching the OS and so on, so that you can testify in court that you have some reasonable confidence that that data has not been modified. So that's, might put tripwire on it, for example, to make sure nobody's infecting your sensor. Another trick that's useful is to make a sensor that has no IP address, that just copies all the traffic from MAC address only. When you can do it, that's nice, but you may not be able to do a simple thing like that in a big complex network. All right, so make sure your monitor is receiving the traffic you need, that your hardware can keep up with with your goals, and you test it. So have some kind of known traffic that should trigger an alert that's not actually harmful, and test it out to make sure you're picking it up. Once you've got all this data, now you have to analyze it. The standard is Wireshark for small investigations, where you can load the data on one machine relatively fast and analyze it. It has this nice protocol decoders that understand every protocol and good search functions and graphics functions. But if you're looking at a lot of data, you just do everything in command line tools with things like a TCP dump. Anyway, Wireshark packet captures become unwieldy and hard to use, around a gigabyte or so. Even 100 megs can be annoying. So usually you want to filter the traffic just by some category first. Yeah, MAC address can be fake too. Yes, absolutely. And you almost never catch the MAC address anyway for a lot of the traffic. As soon as you pass through your router, the MAC address is gone. Yeah. Anyway, so here's a scenario from the book. So here's they have somebody attacked the user's desktop system, and they ran RAR, which is a decompressor, and FTP on this desktop system. And you have complete packet captures. So you look in the Prefetch folder we talked about that shows you what has been launched recently on that machine, and you see when FTP was executed. So now you interview people and tell you that nobody should be using RAR or FTP on there. So this is apparently enemy attack. So you find FTP sessions, 2 are active, you download, there are PCAPs you can download, and I did and analyze them as it's in your book. So you can follow a TCP stream to see this is unencrypted traffic, so it makes it easy. And if you follow an FTP stream, you'll see the communication. So here it is with a username of Frank and a password of Frank, logging into something, and then doing a binary transfer. So this is an attacker doing something nefarious. Obviously, at your company, you'd probably never let anybody have a username and password like that, I would hope, because that's terribly insecure. This is some attacker transmitting either data they're stealing or malware to come back down. So they bring down this file. You can capture it in Wireshark and get the full RAR packet capture. This is an ASCII dump of a binary file. You can save it as RAW, and you'll get the entire RAW file called file.rar, and then you can open it with WinRAR tool to unzip it. Now, this is an encrypted RAR file, but both zip and RAR have the property that even if they're encrypted, you can still see the names of the files inside there. The file names are not encrypted, only the contents. So you can see what's going on here, and it looks like Android manifest and encrypting files and so on. All right, so the RARs are password protected. All right, you can try to crack the password on the RAR, but that's probably too much bother. Then you can detect whether things are automated or not. Notice here, here's a username and here's a password, and notice that this username goes at 2 seconds in, and the password goes at 3.9 seconds in. So if this is not an automated process, if this was a script, there would only be a small fraction of a second from one step to the next. This is a real human typing it in, and you can often find typographical errors too. So this is a real person at the other end here, not an automated process. All right, and so here's one of the files that was moved down, and you can see it had something called pwdump in it. And even though you can't extract it, that's a known hacking tool, one of the tools that steals password hashes off machines, Windows machines. So we're obviously under attack. Somebody's downloading hacking tools, trying to steal Windows password hashes so they can do lateral movement. All right, and that's an analysis of what happened there. So here's another one, kind of one I've seen a lot, Webshells. People had me cleaning off servers for this. So you have a port scan coming from inside your network. Somebody is scanning your network. And of course, nobody's supposed to be doing that. You can check. So this is apparently an attacker that has got inside your network, and now they're scanning to try to perform lateral movement and take over other machines. So look at your server logs. You see a large number of requests. That's from an external address. All right. And so then they have many different pages requested, and then they find a login page, and then they have many requests to the login page. And if you've done the extra credit Snort, Boss of the SOC project, you can analyze someone just like this. They use an automated tool to scan your website until they find a high value target like a login page, and then they use a script to try many passwords on the login page trying to break in. This is a very common pattern of attacks. So many post requests to the login. Once they get in, then you're going to see a lot of GET requests to a PHP file containing commands with Windows commands. So what this means is they tried to log in to something like a web WordPress control panel. They managed to get in, so now they could upload a file. They uploaded a PHP shell, and PHP shells let you just put commands in the request, and now they're executing at the other end. So they're executing these Windows commands. And so in Wireshark, you can see in this case, the data is encrypted with HTTPS. Now, in the old days being like maybe 8 years ago, you could actually decrypt HTTPS traffic if you had the key from the server, if it was your HTTPS server. But because of Snowden revealing that the NSA was in fact spying on everybody, everybody jumped forward to TLS 1.3, which has perfect forward secrecy, which has a unique encryption key for every session. So you can't do that anymore. So this became a lot less useful. There is an option in Wireshark to import the key and then decrypt the traffic, but it will only work on older versions of TLS, so it's not going to work on a modern server. Anyway, but you can see the decrypted data down here, and you'll see here it is posting something to login.php. Anyway, you can export the decrypted data from Wireshark But like I say, you're unlikely to be able to do that with modern traffic, but you can get decrypted data. And you can see where they uploaded a PHP, and here's what a PHP shell looks like. They'll send a request, and they'll have a parameter with CMD, so like a command in it. So it'll be sending commands up. So here they are, they got the file up there with this post, and now they go to there and send a command equals echo, command equals unzip, command equals run this batch file, net view, task list. Those are a series of commands executed by the criminal trying to do things. And from the speed with which they're going, this is probably an automated attack. All right. So here's the list of the commands you see. So here it is, creating a new user, net user backup with a username backup and a password or secret. Here they are adding that user to the administrators group. So, you know, this is a common backdoor being created. So now they're going to be able to come back later with that special account. So NetWitness Investigator is one of the tools to help you here. It will supposedly make it easy to visualize traffic. I didn't find it tremendously useful, but it's open source. You can see the traffic sorted by protocol in a graphic interface. The commercial products that cost money are a whole lot prettier and easier to use. All right. And so then you can collect logs from your network devices, of course. Your firewalls, routers, servers have logs, and your DHCP servers and everything else. So you can configure them to store logs of the necessary requirement. One thing I found when I wanted to detect these PHP shells on one of my servers, I found that I had to turn on Apache forensic logging to record the entire URL of every request, which is pretty expensive. That slows down your server. That's not something many people want to do in production. But that's the only thing I could find that made it possible to easily detect this on a naked Apache server. And another reason why I'd be more secure if I had a separate firewall, making a firewall log of what's going up to it. Anyway, all right, so you take all these sensors. Your IDS sensor might catch the attack. Your host-based sensors can detect things that a network sensor can't because they can look at logs on the machine as well. And so anyway, you can see failed authentications and so on. Your server-based logs tell you what's happening on one system, but they might be erased because the attacker often gets the ability to execute commands on a system. Your network logs are probably harder for the attacker to erase, especially if they're properly secured. So that's one of many reasons why it's very valuable. Now, you do have to have log aggregation. As I mentioned before, you have to send everything to one central place and have a powerful system there like Snort to analyze all those logs. If you just have logs scattered on all the devices, then it's going to be painful and inefficient to find out what's happening. And when you do that, the two big issues are the logs are all in different formats and the timestamps might be a problem. So it takes some effort to set it up correctly. All right. Let's take a look at the other Kahoot, which is here. All right, we had 10 last time. I'll wait a little bit, see if we get 10 this time. All right, looks like 9 is what we're getting. All right. All right, intrusion detection or surveillance, but not both. That's your IDS? All right. All right, which one lets you use custom decoders written in Lua? That's Wireshark. This is both why it's powerful and why it's insecure. It has tons of these decoders, so it understands every piece of network traffic, but since they just have a large community of volunteers submitting those decoders, some of them have security flaws. All right, which item makes sure that your operating system files are intact? That's Tripwire. Good. All right, and the file format used by hackers to execute commands on a server. All right, and it's PHP shells are what I was talking about, a common hacking technique for web servers. All right, so Wilson, and K10, and Juarez, good. All right, so I see a comment in the chat, which is interesting. He says that pfSense does not have the year in the timestamps, which is kind of rude, and they say they're going to improve it, but that's pretty harsh. All right, I'm going to stop the recording and process this video. If any